Hello everyone, I'm Meesha Tandon. I'm an architect, town planner and water sector expert, catchment management to be more specific. And I'm going to talk about decentralized water resource management, preparing for climate change. What I'm going to do is I'm going to talk about two things. One is a study that we've done in Himachal Pradesh, and one is a practical solution that we've implemented in Maharashtra, and now we're talking about implementation in Madhya Pradesh. So these are some of the impacts of climate change. I'm sure everyone here knows about them, but I'll just highlight 2 points that A, the temperatures are going to increase, and B, the rainfall intensity is going to increase. So talking about the case study, anyways. Um, so we did a rainfall runoff modeling for around 13 years of data, and we saw that there are around 4 catchments that we did the modeling for. The city has recently taken up more water supply sources, and it's nearing 38 MLD of supply, but there's still a shortage, especially during the lean season. The model runs that we did, they showed that one of the catchments has a higher potential for water yield, but at the same time, the catchment is also more potentially sensitive to the impacts of urbanization, especially during the lean flow period. Now, yeah. So I don't know how much is visible from here, but the graph on the top is a catchment response from a forested area, and the graph from below is a catchment response from an urban area. The blue lines indicate the rainfall, and the red lines indicate the runoff. Now, if you see in a forested catchment, the amount of lean period flow, which is the base flow, which is, the amount of runoff that is still being generated when it's not raining, and it's, meeting your rivers and your water bodies, is significantly higher than what is happening in an urban catchment. Also, what we find is that, in a forested catchment, there is a time delay. It'll rain today, but it'll take time to reach the rivers. So that means that you're not going to get immediate floods like you get in urban areas. Okay, so I'll just tell you what we found in the case studies. So, there were certain factors that we identified were very important in determining whether a catchment is able to yield the kind of, runoff that we would expect or not. One is that the topography of the catchment is very important. The other is the land use, which I'm sure all of us know. But what is very important is that whether your catchment has a large area under a forest cover or not. If it does, then it is very highly beneficial for any people here are aware of that. But, this finding was kind of reinstated in the work that we did there. Now, what this also means is that, I'm sure all of you are familiar with Himachal Pradesh, and we see a lot of these springs flowing through the terrain while we are going around. So what are these springs and where are they coming from? Have we ever thought about it? So, what happens is that in the Himalayan region, because of the topography, thank you very much. Yeah. Yeah. So because of the, now I can't see the presentation at all. So because of the topography, the rainfall that falls, it takes some time to reach the river, and that leads to, a lean period runoff. When your rivers are actually going to run dry, you actually get some water in your rivers. So it is very, very important to conserve these springs. And at the same time, it is very important to understand that these springs are under a lot of stress due to urbanization, and these are the ones that are disappearing the fastest. So, we definitely need to save our rivers, their tributaries. But at the same time, it is very important to conserve these springs also. And I think one of the states in the northeast, I think if I'm not mistaken, it's Gangtok, they're amongst the first one who are actually taking measures towards a spring management plan and conservation of these springs. So that's my point from the Himachal case study. Now I'll go to the Madhya Pradesh case study. Uh, what you see, okay, again distorted. So on the left is a Kundi Bhandara, which is a very unique feature in Madhya Pradesh. It is an underground tunnel of water which was built during the Mughal era. It is at the at the foothills of the Satpuras. And this tunnel is approximately 100 feet below ground, and it runs from the foothills of the Satpuras right down to the Tapti river. And along the length of this Kundi Bhandara, there are wells which have been built to go into the Kundi Bhandara and to extract water from it. And believe it or not, this is a Mughal era structure, and till date it is being used for water supply to the city. Not the only source, but definitely a source for the vulnerable population. And the good thing about Madhya Pradesh is that they have actually been able to realize the importance of these traditional rainwater harvesting sources. And they are taking measures even under their climate action plans and strategies to revive as many of these decentralized wells and bowdis as they can. Now the image on the right is a bowdi. It's, it's something that is more of a private structure, but it was built several hundred of years ago. But the important part about this is that this is probably one of the deepest wells or bowries I've come across. And it's not because it was built that way. It's like this because every summer it's dug deeper and deeper and deeper and deeper. And for decades they've been doing this, and finally they've given up when they've realized that the cost of digging is more than what I can spend on other sources of water. So now coming to the solutions that we're working with these municipalities in Madhya Pradesh. This is a school in the city, which is a government school, where they have taken measures to tap rainwater from the rooftop, and they've built percolation pits to recharge it. This is not one of the best methods, but at least they've taken an effort. So what they've done is they've made these pits, but they have been provided with big brick bats, which are clogging the pores of the soil, and in due course, it will stop recharging. So what we're doing there, we are proposing a green school initiative where, if you can see from the top there, these are rainwater filters, which we are proposing in partnership with an organization by the name of Waterfield. These rainwater filters, what they do is from your rooftop, whatever runoff you get, it's going to have leaves and some debris every monsoon. So these are going to use centrifugal force to remove the debris from the rain, and then those pits for recharge are going to recharge this. And then what we do is we connect these pits directly to the bore wells. So your abandoned bore wells are going to get some water. Thank you. So even the abandoned bore wells in the area can get some water. The bore well in this school is proposed to be linked to one of the slum areas where they do not get that much of water. So that's how it's going to be useful. We are also proposing decentralized composting there, along with the urban agriculture within the school campus and some solar panels. Okay, this has also moved a bit, sorry about that. But we are developing some caricatures. This is a character by the name of Didi, and using these to educate the children in the school on climate change and water and hygiene and sanitation. Training from municipal staff also, and what is also important is that we are trying to develop a platform where the citizens can come together and start a dialogue on water. Oh my God, that. Sorry about this, this is majorly messed up. But so this is another case example from the same city. There are certain bore wells in a municipal garden which are being used for horticulture. And along the edge of that garden, there are housing blocks of State Bank of India. So, you know, these bore wells are now drying out. Okay, something is clear here. So there are bore wells located, and then you have housing blocks over here. So these bore wells are drying out to the extent that, you know, you can only use them for 5 minutes a day. So the municipality is really concerned about it, because otherwise they'll have to use water tankers or drill another bore well. So what we have proposed is that, because, you know, groundwater aquifers are very, very clean and they need to be maintained that way. So it's very important that we try and not contaminate the aquifer. So we are using rooftop rainwater harvesting to recharge these bore wells. As I said, there are two options. Either you store the rooftop runoff into tanks from where you can use it for horticulture, or like the previous slide, you can build these pits and connect them directly to your existing bore wells, which are functional or defunct, whichever way, and then they can directly be used for recharge. So this is it from me. Thank you.